Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Now we are going to see about the classification of nanomaterials and the properties of nanomaterials. Classification of nanomaterials is based on different things like dimensions. So based on the dimensions, the nanomaterials are classified into 0-dimensional, 1-dimensional, 2-dimensional and 3-dimensional. So when this classification based on number of dimension, it's not confined to the nanoscale range. That is, dimensions may be larger than 100 nanometers. So for example, if you take for the 0-dimensional, all dimensions are in the nanoscale range, that is between 1 nanometer to 100 nanometer. Okay, so example for that are nanoparticles, quantum dots, nanoshells. 1-dimensional nanomaterials are those which have 2 dimensions are in the nanoscale range and 1 is in the larger scale range. That is, it will be larger than 100 nanometer scale range. So example for that are nanowires. So the nanowires, they have 2 dimension which is in the nanoscale range, that is from 1 nanometer to 100 nanometer, and the third dimension, that is nanowires, will be long. So they are not in the nanoscale range. They'll be more than a nanoscale in the microscale range. Then nanotubes like carbon nanotubes, then nanorods, nanofibers, all these things have 2 dimensions in the nanoscale range, and the other third dimension will not be in the nanoscale range. So 2-dimensional nanomaterials, 1 dimension is in the nanoscale range and 2 are larger than the nanoscale range. That is, the 2-dimensional, only 1 dimension is in the nanoscale range. So example for that is thin films, nanolayers, nanocoatings, graphene, etc. All these things are the 2-dimensional nanomaterials. In the 2-dimensional means we have to remember that only 1 dimension out of 3 dimension will be in the nanoscale range and the other 2 will be in the larger scale range. 3-dimensional nanomaterials, they are not confined. They are related to the bulk materials composed of nanoscale building blocks or features. Okay, for example, nanocomposites, nanostructured bulk materials, nanoporous materials, all these things, they come under the 3-dimensional nanomaterials. Okay, then next is the based on composition. So first is the carbon based. Okay, so the nanomaterials are next is classified based on the composition. Carbon based. In the carbon based, you have fullerenes. Then fullerenes, they are 0-dimensional carbon nanotubes, which is of 1 dimension, graphene, which is of 2 dimension, and the carbon nanofibers, which is of 3 dimensions. Okay. They are known for the exceptional strength and electrical conductivity. Based on the carbon based, they have a good strength and good electrical conductivity. Next is the metal based. Gold, silver, iron, platinum nanoparticles. So these exhibit unique optical, plasmonics, okay, then magnetic and catalytic properties. So when the nanomaterials, these of gold or silver, iron, platinum are there, they exhibit a unique optical properties. Then metal oxides. Okay, so the ceramics is an example for the nanomaterials based on the metal oxides. Okay, so titanium dioxide, zinc oxide, iron oxide, alumina. So these are used as catalysts, sensors, pigments, ultraviolet blocking, etc. The semiconductor nanomaterials. Okay, the next category is semiconductor nanomaterials. They are the quantum dots. Cadmium, selenium, cadmium, sulfur, silicon, germanium. All these are the examples for the semiconductor nanomaterials. Their unique properties are their size tunable, optical, and they have a very unique optical and electronic properties. So next is classification of the nanomaterials based on polymer, that is polymer based. They are they are the composite materials. They call them nanocomposites. There are also nanofibers also included in this. Dendrimers, polymer nanofibers, polymer nanocomposites, polymer matrix with nanofillers. Okay, so these nanocomposites are nothing but they have a matrix. That is, matrix is the it's a continuous phase, and you have the nanofillers. Okay, the fillers are filled. That is, the nano types of fillers are filled into that continuous phase. Okay, so they are actually the polymer matrix with nanofillers. They are the polymer nanocomposite materials. Okay, they are used for enhancing the mechanical properties, for drug delivery, etc. The property change at the nanoscale. So there is the properties of nanomaterials, the change at the nanoscale levels. Okay, that is increased surface area to volume ratio. As we know, the nanoparticles are very small in size. As the particle size decreases, the proportion of atoms on the surface increases dramatically. Okay, this leads to higher reactivity, catalytic activity, and different interactions. So this is a very good properties of the nanomaterials. And next is the quantum confinement effects. So this occurs when the electrons are confined in a very small space. That is, they are comparable to their wavelengths, right? So at the effects, electronic and optical properties, that is, the optical properties, for example, it's the color change in the quantum dots. And next is the energy levels become discrete rather than the continuous bands. So the energy level will be in the discrete forms. So these are the property changes at the nanoscale. We will see the properties of the nanomaterials in the upcoming video. Thank you.